Each containerized unit has two UV reactors arranged in parallel. The piping is 12-inch diameter, and if you look at the picture to the right, you can see the inlet side on the very right side of that picture. Water flows along the pipe to the left and enters the bottom of both reactors. Each reactor has isolation valves, so you can run one and leave the other one shut down, or you can run both. Water floods the reactors up from the bottom and overflows out the top. The flow then recombines and exits the container to the left of that picture. So next I have a short video to show the actual field setup on site. I'm walking alongside the generator on my right now, and now we're going to swing around the back and have a look at the generator's control panel to give you an idea of power consumption. So we're running at 480 volts AC, 260 amps. So that's 130 amps per container. And now we're going to swing around the back of one of the containers now and enter through the reactor room. And you can see the two UV reactors with their corresponding shields installed. Water again flows in through the bottom, floods the reactors and flows around the quartz thimbles and then exits through the top. You can also see some sample points here on the inlet and another one on back here on the outlet. And I'm showing the 4 isolation valves in blue. Next we'll have a walk down and have a look at one of the control panels. And we can see the dosage of 3915 millijoules per centimeter squared being displayed, as well as a flow rate, in this case 37 cubic meters per hour. And I can scroll through the screens here and I can also display an actual UV intensity, in this case 1.44 milliwatts per centimeter squared. And the other reactor has its own dedicated control panel and it's displaying the same type of information. So we have a dosage, a flow, and I can scroll down again and get the intensity. And here is the actual controller for the flow meter. And now we're going to exit again. And next we have a couple of pictures to show what the inside of each reactor actually looks like. On the left, you can see the 12 lamps arranged around the reactor head. In the center, there's an electric motor which drives an automated wiper system. This activates on a timer and sweeps the quartz thimbles every 6 hours. In this way, the thimbles are kept clean and free from debris. The right picture shows what the reactor would look like if you were looking down the outlet from the top and inside the reactor. You can see the quartz thimbles are arranged perpendicular to the direction of flow, which in this case would be towards you and coming out of the picture. Next we have a picture of an actual UV lamp on the top and its associated quartz thimble on the bottom. The quartz thimble looks like a big test tube. The outside of the quartz thimble is in contact with the water while the UV lamp sits inside and stays dry. The lamp is never in contact with the water. These lamps run at about 900 degrees Celsius. The operating voltage is around 1400 volts and the output power is 3500 watts each.